So how to do this? Show that the relation R in set 1, 2, 3 given by R is equal to 1, 1, 2, 2, 3, 3, 1, 2 and 2, 3 is reflexive but neither symmetric nor transitive. Okay. See, for my satisfaction, I just want to ask one question. So what is there? So we have the set A, which is given as 1, 2, 3. Can you tell me all the ordered pairs that are possible? So how many elements does this contain? How many elements should the other set A contain? Obviously 3. When you do the Cartesian product between them, how many outputs are expected? You have 9 ordered pairs. What are the 9 ordered pairs? If I do A cross A, then I'm going to have 1, 1, 1, 2,
1, 3.
Okay. 2, 1.
2, 1, 2, 2, and 2, 3.
Very good. Next, obviously 3, 1.
3, 1, 3, 2, and 3, 3.
So, yesterday, if you remember, I gave you a block diagram. What did I say? This will be given to us. Then what is the next operation we do? You do the Cartesian product of the set to itself, A cross A, due to which you get set of ordered pairs. From those ordered pairs, what are you supposed to choose for it to be called as a relation? You take a subset where that subset can be the complete set also. But what did I do in this problem? They are giving us some relation. We don't know how it is defined. We are not bothered about it. They gave the numbers directly. There is some relation R which is defined as 1, 1, 2, 2, 3, 3, 1, 2, and 2, 3. All of them are they taken from the set? Observe. Is everything a part of the set? That is why we call it as a subset. So what are the elements that are taken? 1, 1, 2, 2, 3, 3, and they have taken 1, 2, and 2, 3. So these elements are not taken. So how many are removed? So how many elements do you have? 5. Here you have 5. Out of the 9, 4 are not taken. I hope you are able to visualize what it is. Right. Now, if at all you define a relation of this format, what is that we are expecting? We need to prove that this kind of a relation is reflexive, but not symmetric, not transitive. So for it to be reflexive, what is the first thing that we need to do? A comma A should be there. Okay, I just want to twist and ask, had this element not existed in the relation, in the question itself, had they not given this 3, 3, can I call it as reflexive? Why? Can you come again? So you are saying 2, 3, the reverse of it. 3. Okay, 3, 3 is not given. Suppose I give a question like this: R is equal to 1, 1, 1, 2, and 2, 3. Is this reflexive now? No. No worries. I don't know. Yeah. Range or they were talking about codomain? Okay, codomain. I want you all to do one small thing. Go and read the statement for the text. So can you read it now? When is it said to be reflexive? When A belongs to A. Meaning, every element that is present in this capital set A should be having the counterpart. Counterpart means this one. So if I call this as the input, I'll always speak in terms of input and output going forward. Okay, when you write something in the ordered pair, the first number I call it as input, second number is called as output. So for it to be reflexive, if only one element is taken and written in the format such that the input and output is same, it is not sufficient for it to be called reflexive. What should happen? Every element that is present in the set A should be written in the form of A comma A. So in this question, if either of the things were missing, even if 2, 2 or 3, 3 was missing, it would have not been reflexive. Whereas in this question, what has happened? What did they give us? Okay, so I cannot put up this. Okay, this is there. Sorry. Right, since this is there, it is reflexive. So what will you write? Since 1, 1, 2, 2, and 3, everything belongs to R. For all values of A that belongs to set A. For all values, all the values 1, 2, 3 belong to the set A. Everything has a counterpart of same value. It is said to be reflexive. See, the challenge in this chapter is you can understand the concept, but they expect you to present it well. If it is MCQ, you can just put a tick and go. Okay, wherever subject is there, they expect you to write these statements. That is why I'm stressing this. Am I clear? Next, they told it is reflexive, but we need to prove that it is not symmetric,
And not transitive.
So, for example, if I take 1, 2, 1, 2 is already a part. So I told you how to approach symmetric. What did I say? Symmetric and transitive. We wrote something in the left hand side, something on the right hand side. Left hand side was assumption. Right hand side was condition that we need to derive. So 1, 2. So what I do is, since 1, 2 belongs to R, but what is missing for it to be symmetric? 2, 1 does not belong to R. It is not symmetric. Okay. Similarly, for it to be transitive, if condition has 2 ordered pairs. So what do we have here? Since 1, 2 belongs to R and 2, 3 belongs to R, but 1, 3 does not belong to R, it is not transitive. So that's it's very simple problem, but these are the minor points on which you need to concentrate. So the only point is for reflexive, I want that to get registered because I've seen people doing mistake. They see 1, 1, 2, 2, they write it as reflexive. All the elements should have. For example, if there are 9 elements in this, how many such ordered pairs should you find? You should find 9 ordered pairs. And how should those 9 ordered pairs look like? They should have the same value 1, 1, 2, 2, 3, 3 till 9, 9. Are you able to understand? So that point, please put in your mind strong. Please make a note of this. This is the solution. So you can have a look at the solution of how they are. R is reflexive since 1, 1, 2, 2, 3, 3 lie in R. Also, R is not symmetric. Why? As 1, 2 belongs to R. The assumption is there. But 2, 1 does not belong to R. Similarly, R is not transitive as 1, 2 belongs to R. 2, 3 belongs to R. But 1, 3 does not belong to R. That's all you need to write.